circumstances.
I just knew Dylan because he specifically said Dylan.
Oh, interesting. All right. So which ones were y'all able to do for the people who did attempt?
22, 23, 25, 27, 28. 29.
Okay, so everything except thermochemistry. Okay,
Yeah, chemistry.
that's understood.
Yeah, y'all will be going over that tomorrow on Friday.
Exactly.
And we'll be.
And we just have to, video lessons are due tomorrow, so I haven't done them.
Brett, you have anything else to-
So. Okay, so if you haven't attempted this already, please try 22. So I only saw one person raise their hand. Did everyone else try these problems? At least? If not, it's okay. It's just, we said it would best help you if you attempted it before coming. But anyways, if not, I'll give you about, let's do 1 minute here to see how far you can get on 22. Okay. Okay. 4 more seconds. Yeah. So off the bat, what is the equation? Wait, are we recording? Yeah, we are. Okay. What is the equation that comes to mind when you see this problem?
I use the pressure and volume is equal to.
The ideal gas equation?
Yeah.
Okay. Yeah, so
I just rearranged it and changed it to the moles to mass divided by, or no, but you can use the, yeah.
okay. So yeah. No, I sent this out through email, or Rich sent it out.
What sort?
She's asking if we have a physical copy of this.
Yeah, we don't have a physical copy.
It's like, it would be like 27 pages long.
Or wait.
So we don't have enough money in our funds to print out 27 pages worth of stuff for each student. Okay, but yes, the first thing that comes to mind is the ideal gas equation, right? V equals nRT. Why? Because we're given a temperature, we're given a volume, we're given moles, and we're asked to find pressure. Right, so we can rearrange this to solve for pressure, so you get E equals nRT over V. And 20 to find the temperature in Kelvin, you would just do 26 plus 273.15. Right. Some people just do 273. I've always seen it as 273.15, so that's what I always do. And this gives you 299.15 Kelvin, right? So that's just me converting the temperature from Celsius to Kelvin, okay? Now we have everything we need. This in liters is equal to 0.075 liters. We can just start plugging everything in, right? So 1.47, that's -3 moles. And then the ideal gas constant, 0.0821. And then the temperature, which we said is 299.15 Kelvin over the volume, which is 0.075 liters. And I got 0.4813 atmospheres, right? But it's asking for it in torque, right? We have to make sure we read the equation, or not the equation, the problem. It's asking in torque, so 0.48138 atmospheres is We know what's the conversion factor from atmospheres to torr? 760. 760 to what? To 1 atmosphere, okay? Yeah. So 1 atmosphere is equivalent to 760 torr. And when you do that, you get 365.8 torr. If you did it on your own, is that the answer you got?
Yes.
Yeah. Great. Yes, good job, Jasmine. Thank you for doing it. You want to do number 3 or 23?
All right, let's go for it.
All right, so you don't have to use it. All right,
Number 23. So what is the density of xenon at STP? So right off the bat, right, we'll be using our magic equation of the density of a gas. Can anybody tell me what that is?
I use the ideal gas equation, but I changed a moles mass divided by the mass. I'm just rearranging it.
Yeah, pretty much. So you have your mass, right, over volume equals pressure times molar mass over RT. Now it does say, right, at STP. STP is what? Standard temperature and pressure.
1 atom and 273.15 Kelvin.
Yeah, it's actually 1 atmosphere.
or 18.
Yeah,
Well,
I
one,
read it 18 atom.
yeah, same thing here. Yeah, to 273 Kelvin. So mass over volume, right? This is what we're solving for, because that's what density is. Mass over volume. So then we have our pressure, right? Our pressure is going to be equal to 1 atmosphere, since it's STP. Then, right, we'll look at the molar mass of xenon, which is going to be 131.294 grams per mole. And again, you can find that by looking at any standard grade periodic table. And then R, right, is your gas constant, which is 0.0821. And then your temperature, right, is going to be your temperature at standard at STP, which is going to be 273 Kelvin. All right, let's make sure everything works out unit wise, because that's the main thing. So, right, we have 1 atmosphere. Anybody know the units for R? Yeah, exactly. It's the atmospheres times liters over moles times Kelvin. So what's gonna happen, right? Your Kelvins on top and bottom are gonna cancel out. Your atmospheres on top and bottom are gonna cancel out. And your moles on top, well, technically they're both on bottom, but you can multiply this one by moles to get rid of that. So those also cancel out. And then you're left, right, with grams per liter. Grams is a mass, volume is liters. So yeah, everything checks out in the end. So right, when you plug this equation into the calculator, we get, or not equation, like when we plug in these numbers into the calculator, we get 5.85 grams per liter. That's the density of xenon at STP. Questions about any of that?
Anyone on Zoom have any questions? It's good to ask your questions now before exam time comes around, right? No questions. All right,
Just remember density, right, equals P mark, pressure, molar mass over RT. Density equals P mark.
you said it makes sense on Zoom.
Right. So if it all makes sense, we will move on to the next question, question 25. So, right, this ideally should take what, around maybe 2 minutes to do on the test? Most likely.
This one, I'd say around 2 minutes max, right?
Yeah.
We
so
know.
We're gonna give you all about 2 minutes, go ahead and solve this problem right here.
Sorry, we can't bio.
All right, so you got a minute and a half to solve this question. Okay?
Oh, wait, what's the candy, the surprise? Is there?
I said Friday. Did you see the message?
Wait, it's for these problems though, right? No.
If you finish them before.
Yeah, I finished them.
Okay, yeah.
I attempted. Well, wait, do you know what type of candy is it?
It's gonna be chocolate, because that's your favorite, right? I remember you saying something like Starburst or anything like this.
Reese's. Oh, that was doing this before?
Long time ago.
All right, but about a minute left.
Okay. And this is why we say, attempt these problems before you come to these sessions, so you can see what you know and what you don't know. Because if you're just following us along, you can say, oh, that makes sense, that makes sense, that makes sense. But then once you start doing it by yourself, you're gonna say, I don't know where to go from here. So if you identify where you don't know if you identify those gaps, when you come to this session, you'll be able to fill those gaps. So that's why we say you should attempt them before it's time.
30 seconds.
Let the alarm go off or just.
I changed the alarm actually.
How many people on Zoom, without telling me the answers, how many people have finished on Zoom? I know this is for the people that haven't done it. I haven't done it already, so like admin probably already done. Okay,
All right, and that's time.
Dr. Armand.
And time. Because Pokemon music will be for later.
Okay.
Don't worry. So the density of a noble gas is 2.71 grams per liter at 3 atmospheres and 0 degrees Celsius. Identify the gas. I guess we're being nice and saying please. So how would you go about solving this problem? How would y'all do it? Yeah,
You'd take your ideal gas formula and reconvert it to solve for molar mass.
pretty much, yeah. And as somebody said on Zoom, it's the same equation as we did for the last one. So your mass over volume, so in other words, your density, so I can rewrite this as V, and then equals pressure times your molar mass over your RT. So what do y'all like doing? Y'all like plugging in the numbers first or solving for the variables first?
So solving for the variable, then
That's the way to do it. That's the way.
That is not the correct way to do it. I mean, it's still correct. But I plug in the numbers, then I do the algebra.
No, that just confusing me. Number, that is confusing. Why do you look at the numbers?
Point being, I'll solve it out. I'll solve it out using. So D equals pressure times molar mass over RT. So then you multiply both sides, right, by RT to get the, so the whole point is to get the molar mass by itself. So D times RT equals pressure times molar mass. So we can divide both sides by pressure to get the molar mass of the gas, because that's at the end of the day is how we're going to identify it. So the molar mass equals density times RT all over P, pressure. So now, right, we can go ahead and plug in our numbers. So molar mass equals density, which is 2.71, multiplied by 0.0821, and then 0 degrees Celsius, so that's 273 Kelvin. And then divide that by our pressure, which is 3 atmospheres. Yeah, 3 atmospheres. So then when we solve that out, we will get a molar mass of approximately 20.24 grams per mole.
What does that correspond to?
And yeah, you're right.
If it said the gas was a diatomic,
It says noble gas.
Oh,
No,
noble-
no
noble
noble gas is that.
but if it said it was a diatomic, you just,
You divided
yeah,
by two.
divide by 2 to get the element.
But
Well, if you're given the amount of moles, you won't need to do anything.
Okay,
So, all right, y'all right? So the gas is neon. Yeah,
What's the constant for R?
R, the constant is gonna be
0.0821
Yeah,
instead of 0.08206.
it's really the same thing, right? Because 0.08206, that's what I used to use before, but then Dr. Armand's been using 0.0821, so I just went with that. Like, as you can see, right, the 6 will like round up, so that's why it's like 0.0821. If you use 8206, you'll get like an answer like around the same. That makes sense to you all on in class and on Zoom? Questions about any of that?
Okay, next one's 27.
Right. So this, right, it's kind of somewhat difficult, so we'll say 2.5 minutes, to solve this.
About 30 seconds. You done? Okay. Perfect. All right, so what? Okay, I'm going to show you how I would approach this, all right? So the first thing I recognize is it's giving us some volume of oxygen gas, right, at STP. Something comes to mind when I see these two variables, right? And then, or not variable, I see liters and I see STP. And then it's asking me to figure out something with mass, right? I think of that the volume of the gas at STP is equal to the moles of the gas times 22.4, right? That's one of those numbers that we memorized and that we can use when the gas is at STP, right? So in order to figure out the moles, all we'd have to do is just divide the liters by 22.4, which is, so N is equal to 35.5 liters over 22.4. which gives us approximately 1.58 moles of O2, right? And from here, yeah. Can you explain the 22? Okay, yeah, so let's see, when you're solving for a volume per mole. So let's use PV equals nRT. So if you were to solve for V over N, which is the volume per mole of gas, you would get V over N is equal to RT over P, right? So the units here would be volume per mole, right? And at STP, we know the temperature is 273 and the pressure is 1 atmosphere, right? So this actually gives us a constant, and that constant is 22.4. And this tells us that the volume of a mole of gas at STP is 22.4 liters, okay? Yeah, exactly. So 273 times 0.0821 will be 22.4. That's where that number comes from. But you need to know that you can utilize this to your advantage in problems like this, okay? So I'm gonna go ahead and delete that. So if we use the molar ratios that were given, you get for every 5 moles of O2, 1 mole of phosphorus is, or what is it? Yeah, 1 mole of phosphorus is going to be utilized, right? And from there we say 1 mole of phosphorus has a molar mass of what? What is the molar mass of phosphorus?
30.974.
30.974. And that's grams per mole.
Technically, but it doesn't.
Grams. Okay. And that'll give us 1.58 divided by 5. 30.974.
And no, shouldn't it be
Yeah.
P4?
I did
Oh,
multiply the molar mass.
yeah, you're right.
I got,
Yeah, I had that on my key, but I could have sworn that was an error from last
it
semester.
was 100
How many grams?
120.
Well, it's asking how many grams of phosphorus react with this.
Yeah, so you based on the equation. So you multiply it by.
Assuming that's.
Why won't you multiply by 4? Isn't it P4?
I think I got it
Oh,
wrong.
yeah, you're right. What is the molar mass of P4?
123.896.
123.896. Okay, yeah, I see what you're saying. Yeah, I had made a mistake on the key where I accidentally solved for grams of tetraphosphorus decoxide, which is not what the question was asking for, so that's why. And what does this give us? It gives us 1.58 divided by 5 times 123.896, which is, what did y'all get? I got 39.15 grams.
I got it slightly different.
But
I got
how
39.2 to
often-
39. Yeah, I didn't round at all.
Interesting, okay.
I mean, that's all right, like, he'll give you
Yeah.
credit, like, like in a certain range, and that's like pretty close, so you're fine.
And this will most likely be multiple choice, right? So the answer will be,
Yeah, 3 to 6 weeks, right?
are we in chapter 1 still? No, I'm just kidding. Yeah, so it would be 366, which would be 39.2.
But no, honestly, he doesn't really care about sig figs, like going forward,
Okay,
it's generally like 3 or 4.
Either way, she's gonna for choice to get this answer. You'll look for the closest answer. and the closest answer will probably be the same answer.
exactly. Okay, so you could have solved this using the ideal gas equation, right? But that would have taken a little bit more steps, in my opinion. I mean, it's just plug and chug, but it's another thing that if you just know this part right here, I think it'll help you out, right? Just you divide by 22.4 and you get the moles. Okay. How many? Next one would be 28. I'm gonna give you all 2 minutes to work on that. Okay? Want to start? Yes.
There it is in the middle. That'll be iron.
What time will Friday session be?
2:30. Yeah. What was that?
You host like 3 a week. 3 a week on Mondays, Wednesdays, and Fridays.
Make those videos.
Yep.
Yeah.
You should like and subscribe and follow their YouTube channel.
And don't forget to hit the bell so you get notified. I think I only have 2 subscribers, kind of sad. Or I'm one of them.
And now I'm the other one.
Oh, never mind.
Yeah, honestly, that's mandatory. After this meeting, everyone, I'm gonna make a QR code to our YouTube channel.
You have 82 subscribers.
Yeah, really?
You do it.
Yeah, can we get candy for subscribing?
Yeah, you get candy for referring it to people too.
Are you serious? Oh, I'll do that. Yeah.
Just make sure you tell them to comment in a video like so-and-so sent.
Oh, okay.
Yeah, I'll do.
We're doing a giveaway very soon.
Okay, 10 free Alex.
Wow. Private.
We don't have Alex.
Well, that's tough.
So we can, I see.
My good friend, chemistry professor friend.
Yeah.
Team Entropy.
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 They don't get
It's like it helps people get rid of bad homework grades.
You only have 3 videos on your channel.
Hey, get started. Give us a break. Okay, all right, so we're gonna go ahead and get started on 28 now, okay? So, Maria,
Yes,
what's the first thing that came to mind when you read this question?
I need a balanced equation.
Okay. What's the balancing equation here?
It's P4,
Yeah,
it's tetratomic, and then it's 6H2O, and that gives you the pH 3.
is it H2O?
Sorry, H2. 6, you need 6 of those.
Yeah.
And then you need 4 of the phosphate.
Okay. This is the problem. Because it's red. Okay, so, yes, what's the next thing you thought, Maria?
Next thing was I need moles of stuff. I need moles of the reactants, so it gives you grams and it gives you the liters of hydrogen gas and STP, so you can figure out the moles of both of the reactants from that, and then from there you get that you're limiting is hydrogen.
Okay, so that's what okay. That's what I wanted to know was that you recognized you needed to find the limiting reactant, right? And why? Someone in the back, tell me why the first thing you, okay, aside from balancing the equation, what's the first thing you should think of when you see information about both reactants.
You gotta figure out which one's limiting.
Exactly, and I think this is a question that Rich missed on his exam too.
Oh, yeah, I did. That was the only question.
Oh, okay.
But you forgot to find the limiting reactant. So don't be like Rich, okay?
Got it.
Remember, if you see information about two reactants, find the limiting. Okay? It says X, there's no, well, then the one that you have the information about is the limiting. So from here, I'm gonna start with the phosphorus, okay, so 35 grams or 37.5 grams of phosphorus. And we're gonna divide that by the molar mass, which we said is 123.896 grams per 1 mole of P4. Okay. And now we use the mole ratio to figure out how much phosphine is produced, right? So for every 1 mole of phosphorus, we have 3 mole or 4 moles of phosphine. Okay. 4 moles of phosphine produced, right? And I'm just gonna stop there, right? I don't need to go all the way to the grams just yet, okay? And that's gonna give me 1.21 moles of pH3 phosphate. Now, how would you go about solving for moles of hydrogen? Okay, you could use that. What's the other way?
The easy liter conversion that I forgot about whenever I did the worksheet.
Exactly. So we know L over N, volume per mole is equal to 22. Or you can solve for N by doing the liters divided by 22.4, right? Which will give us 83 liters divided by 22.4. Which is equal to 3.71 moles of H2. Okay. Now we just need to convert this to moles of phosphine, and we get 6 moles of H2. That produces 4 moles of pH3 phosphine, and that's going to give us 2.473 moles of phosphine. And so which one is our limiting reactant? Phosphorus, right? So therefore we can go ahead and cross this whole thing out, all that work for nothing, right? Well, not for nothing, it's gonna give us the right answer, right? And then we realize this is our limiting reactant. So I'm gonna go ahead and take this and find the grams of phosphine using the molar mass, right? So 1.21 moles of pH3. And we're gonna multiply that by the molar mass, right? So 1 mole of pH3 has the molar mass of about 33.974 grams, which should give you about 41.1 grams of pH3. Did anyone else get that when you tried?
Yes.
Congratulations. Okay. What about any questions from the people that didn't? Yeah, you good? Okay, perfect.
41.2.
Don't even worry about it. What?
Why would the molar mass of P4 123.896?
Because you have 4 phosphorus atoms and each one is like 30.978.
Yeah, so you have to remember that P4 phosphorus is tetraatomic, right? So it'll naturally occur 4 phosphorus atoms, which each one has a molar mass of 30.974. So we need to multiply that by 4 to get this. Does that make sense?
Yeah.
You want me to zoom in here? I'm gonna give you all a second to go ahead and copy that down. Any questions, people on Zoom, any questions? Give me a yes in the chat. No, sir, thank you. Something is diatomic monoatomic. So that all goes down to memorization, okay? So, let me, while we're waiting for some people to finish copying this, I'll go ahead and say the diatomic elements. What is the mnemonic that?
Wrinkle.
Wrinkle hop, wrinkle hop.
Okay.
You're right.
I'm gonna have no.
It takes so much time to write that down.
You don't have to, you don't have to write it down, you just say have hydrogen, nitrogen, and then what? Oxygen, chlorine, iodine, chlorine, bromine. Okay.
So it'd be
So-
here.
You want warm? beer?
No, it's not.
Yes, they do form the number 7, that is true. So if you look at these elements, they are all on the right side of this. So you get nitrogen, oxygen, chlorine, bromine, iodine.
I never noticed that. That's fine.
And then the only, okay, let's quiet down, just because the mic picks up everything in here. Okay, so. Okay, so, yeah, the tetraatomic is just phosphorus, and then octatomic is sulfur, and then selenium. That's it, okay, but that's stuff that we learned in previous chapters, right? Okay, perfect, and Rich is gonna go ahead and give y'all a couple minutes to work on 29.
Real quick for 29, I just want to make sure of something. Do y'all have that partial pressure statement on your worksheet or no? All right, so yeah, that just. Okay.
No, we don't have.
That's interesting.
Wait a minute.
No, see that, I should have given that to you, I don't know why I didn't, that's my bad. But the partial, try solving it out now if you haven't already.
All right, let's 2 minutes for this problem.
You need a.
You don't have to, it's on the board now.
Oh, I did this wrong. Yeah, I didn't.
You don't want all this.
So we did use a partial pressure.
You don't get credit, you don't get credit.
Oh, wrong. Yeah, me like.
Why? But it's on there. they're doing it. Sorry, he crossed it out because he was just testing out the red marker.
Wait, for the last problem that you worked out, you needed it before finding the limiting reactive, but that was it, right?
Wait, you said we wrote out what again?
Part that's like red,
Oh, yeah, we crossed it out.
because it was
Because
only
it
used
was-
to find the limiting reactive.
Yeah, exactly. And that one was not the limiting reactant. So I like to cross it out because I don't want to get confused. You know, say I accidentally sneezed on the exam and I forgot where I left off. I don't want to.
Like you remember me speak?
Yeah, if I sneeze on the exam, during the exam.
You always remember. I'm so.
Isn't that the thing?
Now this guy takes every single type of partial cost.
Because it's.
I don't sneeze.
Why? It was.
Interesting. Someone hasn't been doing their Alex. Someone hasn't made it to this partial pressure topic.
Yes.
It was the virtual lab.
Yeah.
This is gas. You can't have a pressure as a solid.
Yeah.
All right, and that's time.
All right, Maria.
So let's go through it. Aluminum. Aluminum or aluminium if you wish, reacts with excess hydrochloric acid, form aqueous AlCl3 and 35.8 milliliters of hydrogen gas over water, blah, 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 71 milliliter. How many grams of aluminum react? All right, so what's the first step?
Writing chemical reaction.
That's chemical equation, exactly. So aluminum, and what is our physical state for this? Like, is it a solid, liquid? Yeah, solid, exactly. What about for HCl?
That's wrong.
Aqueous.
Yeah, exactly, because HCl, right, is one of our strong acids. So strong acids will completely dissociate in water. So that's why, right, it's aqueous, because it's water soluble. Then, right, this will produce your AlCl3 and your hydrogen gas. So to balance this right, we're gonna go ahead and say, we need to balance out the hydrogen, so we'll put a 2 there. Oh wait, but that screws up our chlorine number, so we're gonna put a 2 here. So that increases our chlorine to 6, so now we're gonna put 6 here. Then 3 hydrogens, and now balance out our aluminum finally, so 2. Is this what you all got for the balance?
Yeah.
equation? Right, fantastic.
Yeah.
So, right, I'm gonna go to this statement right here. The partial pressure of water at 27 degrees Celsius is 26.8 millimeters of mercury. So who knows about Dalton's law and can tell me what that is?
Total equals PA.
Yeah, exactly. But how would you apply that to this problem?
Would it be?
Yeah, you in the back.
Right. Okay, so you plug it into the P total equals P1 plus P of water, then you use that to find the pressure of the hydrogen gas.
Yes, exactly. Because we're given a total pressure right here of 751 millimeters of mercury. So what we're gonna do, right, is we're gonna do our pressure total equals our pressure of hydrogen gas plus our pressure of that particular substance, water. So then, right, what we're gonna do is, let's keep it in millimeters of mercury for now, because that keeps our subtraction a whole lot easier. So 751 equals our pressure of H2 plus pressure of H2O. So our H2O pressure, right, is gonna be approximately 26.8 millimeters of mercury. So, right, to get our pressure of H2, all we're gonna do is just subtract here, and then we get 724.2 millimeters of mercury. But can we use our pressure in millimeters of mercury and just continue on with the problem?
No, you have to subtract.
Wait, but already subtracted. That is the pressure of.
Atmospheres. Put it to atmosphere.
Or the atmospheres, exactly. So 760 millimeters of mercury, right, are in 1 ATM. So if we solve this out right here, we get 0.952. 9.28, so let's say 9.53. 0.953 atmospheres. And this is right of H2. So now what will be our next step? Well, let me ask you this. Do you guys want the short way or the long?
I mean, I understand this.
There's one vote for the long way and, all
Sure.
right. Short way clearly passes. We're gonna do the short way.
You're going to aluminum.
So the normal way, right, the long way is to use your PV with an RT equation and then just solve everything out and get your volts of H2. Instead, we're gonna do this. So mass over volume, right, the density equals pressure times molar mass over RT. Now, right, we can solve directly for our mass of hydrogen. And it just occurred to me that I have to go back to moles anyway. So now we're gonna use the PV equals RT. I do it at once sometimes. So, all right, so let's do PV equals RT. PV equals RT. So, exactly. So, N, right, is equal to your PV over RT. So your pressure, right, is gonna be 0.953. Sorry, this is like hard to see. This problem has a lot of steps. So your volume is 35.8 divided by 1,000, right? Because we're looking at liters. So 1, 2, 3, that's 0.0358 liters over our R, which is 0.0821. And then our temperature, which is 27 degrees Celsius. But what's that in Kelvin? Sure. We use the boiling, but I normally would have just gone with it. Same thing.
Take your work down into the next problem, so you're.
Yeah. Let me just
It's getting crowded.
this over right here. All right, so we go copy, paste. So we do this part, right? So we get our N, which is going to be a number that I just solve out with a calculator, so.
I'm not getting the right answer.
Point,
So the.
0.953 is 90.0358. Then we're gonna divide this answer by 0.001 times our 300. Solve this out, we're gonna get 1.38 times 10 to the negative 3 moles of H2. We're done, right? No problem, back it up.
Yeah.
Why not?
Grams of aluminum.
Yeah, we need aluminum first. So first of all, we're gonna go to our aluminum. So we're gonna say, what, using our mole ratios, right? 3 moles of hydrogen gas in every 2 moles, right, of aluminum. Using our, this is again using our mole ratio. So we're gonna multiply this number by 2, divided by 3, and we get an answer of 9.23 times 10 to the minus 4. This is, of course, moles of aluminum.
No, I think.
So, right, what's our final step?
Because he knows this.
Exactly, moles of aluminum mass. So 1 mole of aluminum is, I believe, correct me if I'm wrong, 26.987 grams.
982.
982.
I did too. It would the.
All right, they're gonna multiply this one, right, by 26.982. And our final answer is gonna be 0.02490446986 grams of aluminum, but let's be somewhat reasonable and convert this to scientific notation. So 1, 2, 1, 2, you get 2.49. 2.49 times 10 to the minus 2. Yeah, 10 to the minus 2 grams of aluminum.
So the funny thing is, if you didn't do the partial pressure one, you still would have gotten the right answer for the exam. I got 0.0258. So
That's
like,
not the right answer.
no, because if it was multiple choice of the exam. that'd be-
Wait, did you get times 10 to the minus 2?
Yeah, if you're.
It's too far off. More than 1%. Okay. Okay, so I'm gonna go ahead. Okay, I'm gonna.
It's just this problem.
All right, real quick, questions about that? Anybody in Zoom, in person? Speak now or forever hold your peace. All right, cool. Let's move on.
Thank you. Okay, so. So I just wanna go over this problem one more time. So we started with, Maria, I'm about to explain it, okay? And so that way you can learn it, okay? Okay. So we started with the balanced chemical equation, right? That's the first thing we did, right? And then we noticed that the pressure that's given here is the pressure it's the combined pressure of the water, right? Because it tells us it's over water. And it's also the combined pressure with hydrogen gas, right? Because that's what's being produced. So the total pressure is equal to the pressure of hydrogen gas, up the pressure of water, right? We all see how that works. Okay. So in order to figure out just the pressure of hydrogen gas, we have to subtract the partial pressure of water, which it gives us here, which I didn't give y'all earlier, but I did now. Sorry about that. And when you do that, you get P of H2, the pressure of H2 is 724.2 millimeters of mercury, right? Great. Do we all understand? Yeah.
What does water have to do with this?
So because this is happening in aqueous solution, water is going to have some sort of pressure because, yeah, y'all don't learn this yet, but water will escape from the liquid
Maybe
phase.
draw like a diagram.
Yeah, so water it's called vapor pressure, right? So even though you're not applying energy to the system, some of these molecules are still going to escape into the vapor phase. So in this case, the partial pressure of that water, that was a gas, was 26.8. And you don't need to know that for this. You don't need to know why that happens for this class, but you just need to know that you have to utilize Dalton's law of partial pressure. Yes.
That you give us, is that something that will be given to on the test or something that we,
Yeah, no, so this is something that would be given to you on the test. I don't know why I wrote it. I guess I forgot to write
We
it.
learned about the smart vapor pressure in chemistry class.
Yeah, the vapor pressure, that's all Gen Chem 2. You take Gen Chem 2. we learn about-
Yeah, but this is something that you should be able to do without knowing about vapor pressure. Okay? Okay. So with this, we figured out the pressure of H2 in millimeters of mercury, right? We converted that to atmospheres, and we got this as our pressure. We plugged this into the ideal gas equation. And this is gonna be the last problem because there's a class in here after. And we solved for moles, right? Which gave us, where is it? Right here. We solved for moles using the ideal gas equation. Use the mole ratios from the balanced chemical equation to get to moles of aluminum. Use the molar mass of aluminum to get to mass grams of aluminum, right? That's the way we solve this problem. Okay? That's unfortunately, we're gonna have to stop there today, but I can send out the answers to the other ones. Yes, I'll do that.
I will say though, next class, be prepared, thermochemistry, hardest topic all year, so.
That's not helpful there.
Yeah, but it helps to like, be attentive in class tomorrow.
And maybe,
That's all I'm saying.
and if you're, maybe,
would it be? Thank you.
It's all good. I'm so perfect.
yeah, this please.
Thank
You learn this in class. There's a lot.
We lost 3 people. Now we lost another.
So
Yes.
so I'm in.
Yeah, it's like straight gas.
We having a test it's about some chemistry and the test is like.
Yeah, well, Dr. Ahmad's class, I don't think has really started talking about that.
No, we just have, literally going over it tomorrow.
Yeah, so instead of.
We're not gonna go.
No,
Are you off it?
It's next Friday, right? Yeah.
Cause the exam is on Friday. No,
Next Friday.
next Friday. Next Friday?
Yeah, you don't still have time.
Oh my God. Really good.
Stop this Zoom.
Why should I ask you what's the project?
But yeah, read the text, chapter 6.
What does that even mean?
Already.
And he's like, that's what it means. It's an hour. Why is this? I'm not getting.
What